Alright girls, we're going to take a look now at chapter 10. And chapter 10 is all about right angled triangles and Pythagoras' theorem. So, to be able to access the stuff, you need to know a couple of things. First of all, make sure you know what a right angle is, which you would have met last year in first year. A right angle, you'll see the symbol often for a right angle. These three triangles are all right angled triangles. Okay, if you get an exam question and the triangle, it looks like this, you can't assume the angle is a right angle unless you're told. Okay, so you'll either have the symbol like that, or they'll write 90 degrees in it, or they'll tell you to measure the angle and note that it is a right angle. So these three triangles are right angle triangles. They are triangles that have one angle of 90 degrees. And the other two angles are unknown to you. When you have a right angle triangle, Pythagoras' theorem, and a theorem is something that has been proved beyond all doubt, applies in terms of maths. So the first thing you have to get practice with these triangles is making sure that you can label the triangle up as you go around through the triangle. So excuse my searching now, I'm just looking for a different colour. Okay, so the side that is opposite the right angle is always the first one that you label, and that's HYP, and it's always opposite the right angle. Okay, so in these three triangles I've labelled the hypotenuse. The word is hypotenuse. Now I'm going to have the book here to learn how to spell it. There it is, there's the word. I can't spell it, I just write it as HYP. Hypotenuse, when I see the word hypotenuse, it always reminds me of a hippopotamus. So what does the hypotenuse mean? The hypotenuse means that when you have a right angle triangle, the side that's opposite the right angle is always the biggest side in that triangle. Always. Okay. So if this was measured 10 centimetres, this one measured 12 centimetres, this one would have to be bigger than 12 centimetres. And actually, it even goes further to say that actually, when you have a right angled triangle, there is a specific ratio between these three sides that is always the same. Okay, so once you've labelled your hypotenuse, your other two sides are A and B, and you can label them any way you want for this chapter, any way at all. Okay, and the maths behind this says that if you take your hypotenuse and you square it, so we'd say your hypotenuse was 4, you'd put 4 in this bracket, so it'd be 4 squared. It would be equal to the sum, and the word sum means adding, of the other two sides squared. That is what Pythagoras' theorem says. Pythagoras' theorem says the hypotenuse squared is equal to the sum being adding, the other two sides squared. Okay, so what does that mean? What sort of maths am I going to be asked to do? I'm basically going to be doing substitution in algebra. Okay, so hypotenuse squared could be simplified into h squared is equal to a squared plus b squared. And I'm going to be substituting into this equation to try and find out the one that I don't know. So if we take a look at an example, so we'd say here, this one is 4 and this one is 3. So triangle number 1. The question says, find the missing side. And we know that the missing side in this case is the hypotenuse. So I don't know what h squared is. And this is for triangle number 1. Triangle 1. Okay, I don't know what that is. So I'm leaving it as it is. But I do know that side A is equal to 4. And I do know that side B is equal to 3 because they told me that in the question. I then do my math. So I go h squared is equal to, what's 4 squared? It's 16. What's 3 squared? It's 9. So that's h squared. What's 16 plus 9? It's 25. So I've worked out almost all the way to the end. So I can tell you that h squared is equal to 25. But they didn't ask me what the h squared was. They asked me just what that side was, what hypotenuse was, what h was. So I need to get rid of this 2. So the question is, how do I get rid of a square? And the opposite to a square